Hi, welcome everybody for today's webinar on API first integration for microservices. I'm Kasun Indusari and Rob Valuber from Yenlo will also be joining when conducting this webinar. So before we go into the details, let me introduce WS2 and Yenlo. So WS2, I think most of you are aware of WS2, and it's an organization that allows you to build a composable enterprise by leveraging existing assets, existing data, existing services and systems. And as part of WS2 offerings, we have API management, integration, and identity access management solutions. So all these are open source offerings. So you can leverage these products when building a composable enterprise. So Yenlo is one of our long-term partners. So we have been working for last decade or so on building various integration projects, and they are one of our platinum and most experienced partners in the partner space. So as presenters, so I'll be conducting the first part of the session today, and then Rob will be joining us on a real world use case on building microservices use case using WSL platform. So without any further ado, I'll get started with the content. So if you look at the topic for the webinar, it's an API first integration for microservices. So if you're not familiar with microservices architecture, let me try to explain microservices architecture in simple terms. So at the foundation of microservices architecture, it's all about building an application as a fine-grained and independent entity, right? So when you develop a microservices-based application, the first thing that you would do is you would look at the business capability that you want to implement using that microservice. It is more or less a fine-grained business capability, and you build that service as an independent entity, which is running its own process and developed and deployed and even managed independently. So that is the core of microservices architecture. So it's so important to look at how microservices has evolved during last decade or so. So as you know, what we have initially built was we used to build a lot of monolithic applications. A lot of ERP, a lot of CRM applications are built as monolithic applications. So in this context, we have multiple disparate applications, maybe using a shared database. There are a lot of point-to-point connectivity between all these legacy applications. Now, with the introduction of service-oriented architecture, we introduced the concept of a service, more of a coarse-grained service into the picture, where you design and develop different capabilities as coarse-grained web services for the most parts. And when it comes to integration of these services with rest of the other services or other systems such as databases, any existing legacy systems, then we use the enterprise service bus as the integration infrastructure. So this is the central place that we connect all of those different systems. And then on top of that, when it comes to the consumption of different APIs, different services, the capabilities offered from ESB was not enough. So then we brought in the API management into the picture, where you expose a simple API or simple interface to the complex functionalities using this facade type of a pattern. So this is one of the most commonly used pattern even in most of the enterprises. You have a centralized integration layer, then you have an API management layer, and then you have applications or system of record layer. Now, with the introduction of microservices, what we are primarily doing is we are breaking most of the monolithic components in that previous architecture, right? So basically, we are segregating the application server layer into multiple fine-grained services, and at the same time, we are basically getting rid of enterprise service bus layer. So all the integration work that we have been doing are now being segregated into different set of services. So API management layer, usually it's still sits on top of the existing microservices, but the way that you implement the API management layer may be different. Maybe you use the segregation at the API gateway layer, while you have a centralized control plane. Now, this is the typical architecture that is proposed with the microservices, but there are some challenges. Now, if you look at the capabilities that the enterprise service bus offered in our SOA-based architecture, what we can clearly see is there are a lot of a lot of application integration related capabilities that you have to do as part of these microservices. Now, if you look at this particular use case, you have multiple services as well as different proprietary and SaaS-based systems. And when you have to integrate these things, there's no central infrastructure such as ESP. So what you have to do is you have to do all these integrations inside your microservice. Now, the microservices shown in these orange color boxes, those are the services that do heavy lifting of all these integrations. So when you are building this kind of a microservice, you need to have a specific integration technology so that you can easily integrate these existing services and legacy systems. And also you may have an event broker, such as a message broker system, where you can do pub/sub messaging. And on top of that, we have the API management layer. So usually these services, you can, in the microservices terms, we call them smart endpoints and dump pipes. Basically, all these services are becoming smart endpoints, which means a lot of integration capabilities are now being embedded as part of the services business logic. Now, keeping that in mind, now let's look at what is API first integration. Right? So our title is about API first integration for microservices. So we can define API first integration as the process of building reusable business capabilities by integrating or connecting different services, systems, and data, and offer those integrations to the consumers as managed APIs. Now, if you look at this diagram, this is a generic diagram where you have set of services, systems, and data, and then you create different compositions or integrations, and then you expose them as consumable interfaces to the external world. Now, the concept here is that any integration service that you develop will be exposed as a service, as an API to the external world. Now, the important aspect of that is you may have different other services as well, which you may directly expose as APIs to the external parties. So that's another common API first integration use case. Now, if we look at the approaches that we have, we can follow two different integration styles. So the first one is you can define the API first, the business API initially, and then use that API definition to create the integration. So, for example, if you are designing a retail application, then you can build a product API, API at the API management layer. And once you have that API definition, when it comes to the implementation of the product API, then you have to create maybe you have to integrate some existing services, systems, or data. Then you create the integration out of that definition. So basically, this is the top-down approach. Also, you can follow the bottom-up approach where you create integrations first. You figure out these are the things that I have to integrate, and you create a sort of a business capability out of that in the integration layer, and then you decide to expose that as a managed API. So you start from the integration and move. This is using the bottom-up approach. You move to the API management layer. So that is the second approach. Now, if we try to map this into our typical architecture diagram that we discussed earlier, we have a lot of microservices. right? So we can identify different microservices types based on their granularity. So that means we have set of atomic or core services. This can be even Spring Boot services that you developed or existing service that you developed using any other service development technology. And you have proprietary and legacy systems as well as different web APIs and SaaS applications such as Salesforce. So, so on top of that, you can create these different integration services. So this is where you need to use a specific integration technology. So again, we can use the same bottom-up or top-down API approaches when building these services, but it's again totally up to your development strategy. But on top of that, we can have different API services, which are sort of like the API gateway capabilities. This is the place that you use all the different API control plane or API management capabilities that you can just control all the different APIs residing in the API gateway. So this can be a central layer, or this can be a segregated micro gateway layer as well, again, depending on the use case and the requirement. And all these different integration services, they may use different integration styles. It can be request response, or it can be event-based, or it can, based on the use case, you can decide. And if we try to map this to our offerings, WSO offerings. So now we have multiple technologies that you can leverage to build this kind of an architecture. So at the integration services layer, we have the WSO Enterprise Integrator, which is an integration platform that you can use for either centralized or decentralized approach. So in this case, what we have is a decentralized integration use case where you develop integration individually, independently. So by leveraging the micro integrator capability, you can create an integration in the enterprise integrator using our integration studio development editor, so that you can develop a single integration use case which is fully container native and cloud native, so that you can deploy that as a container inside Docker or even inside Kubernetes. Right. So, and also it can coexist with other services such as Spring Boot services and any other legacy and SaaS APIs. And you may use a broker such as RabbitMQ even in the event broker for the event broker requirement. And on top of these services, you can leverage WSO2 API Manager. So this is a typical architecture that you would implement for any API first integration use case with microservices. And also the other use case is you may have some part of your architecture built using this micro architecture, whereas you have still a monolithic component, maybe in legacy ESB, even in this architecture, so that these systems can connect to that legacy counterpart and still realize your use case. Now, in today's session, we are going to look at a simple use case, which is sort of a realization of the same high-level architectural concept that we explained here. So I'll hand over the session to Rob, who he will talk about using WSO platform to realize this kind of a integration use case. Over to you, Rob.
Okay, thank you, Kasun. I hope everyone can hear me. I hope everyone can see my screen as well. And I'm now the presenter. So yes, what we are going to do is we are going to talk about a use case to show you what this would look like. So we heard about the theory about microservices and of course what you can do with WSO2. So it's now time to look at a use case to show this. And of course, this is a webinar, so it's a simplified use case. I will explain the differences between what we've done and what you would do in a real world scenario. In this case, the use case is Yuma Market, a fictional groceries store chain that until now was really into selling groceries through the store. However, the problem is with COVID-19 that we suddenly are way more reluctant to actually go to the store because of people around, keeping your distance and stuff like that. So in this fictional use case, the CEO said, okay, this is the time, this is the moment. Now we're going to implement online delivery, online pickup for groceries. So basically what they've done is they've created a set of APIs that are partly for the customer, where they can add themselves as a client, they can order groceries, they can change the order, but also internal services, of course, where we add articles, add suppliers, order picking, and more of that sort of thing. So when you look at that overview, um, the some of the services are, as I said, the customer API, where you add a new client, you change the client, you order the groceries, and you change your order. The other ones are more towards the internal, where suppliers and articles would typically be done by the people who are responsible for the process, for the assortment, perhaps people for marketing, whereas, for instance, getting a pick list for order picking would be something that a completely different person would do inside of the organization. So here is a sample of the APIs that we've created. So we've added an API to create a new client. We keep that simple. Context is client, resource is new, and we typically do a post. We've also have the opportunity to change a client. Again, same context, and the resource is changed, and the HTTP verb in this case is put. And the same goes for order groceries and change orders. So here you see an overview of a typical API that is sent, the typical payload that is sent to the API. You see a client ID, you see an IBAN number, you see some articles. We're actually working with a database of about 1,000 articles in this example that we can show. And this is an example for a new order, but there's also the possibility to add a new client, again with a payload of that is sent to the client API. And what we're going to do today is we're actually going to take a look at the order flow. So the order service is a typical microservice that has a number of events in it. It also triggers other stuff. So when you do the order, then at one point there will be an order picker that will pick up your list of groceries and will actually also start picking it, either directly if it's for a delivery straight away, or they will schedule it for delivery at a later stage. So when you do that, you suddenly see that although the order service is one part and the pick service is another part, that there are also connections to other systems, connections, for instance, to restocking. So every article on sale has a minimum number that needs to be in the warehouse. If it falls below a certain order, it will actually trigger an automatic process to restock. So it will send out an email or another message to the supplier or distributor saying, I would like to have 5,000 cans of Coke or whatever you need to do. And of course, the notification to the client that the order is ready for pickup, or in case of delivery, yes, we received your order total will be this amount and we will deliver it on this and this time, etc., etc., etc. And basically what you would do, and this use case, by the way, is something that we see unfolding here in the Netherlands for our own eyes. We saw that the major supermarket in the Netherlands now has 4 times as many online orders that they had before this. So suddenly we see the digital transformation and hopefully a digital imagination as a next step happening because of this COVID pandemic. So this is not something that we thought would be a good idea. This is actually based on a real world example, and that's also partly the reason why we chose the things that we are using. So for instance, Kasun talked about Kubernetes, and of course Docker would be ideal candidates to run this in, because it's easier to add resources as far as capability of managing orders than it would be on with another setup. So this is the use case of the order. And before I go into the demo, it is basically good to realize that what you're seeing here is the order flow with some side steps. We're running on the enterprise integrator, micro integrator, in a Docker Kubernetes environment for this setup, as I already said. And what we're using as far as technology goes is, instead of making a connection to a real world payment system, like for instance Stripe. Stripe is the sample implementation, for instance, for monetization in the API manager. It is also we're also able to connect to Stripe from within the enterprise integrator, micro integrator. What we've done is we basically use the internal capabilities of the enterprise integrator slash micro integrator to show this whole flow. So this is the use case order. I will talk through it. I have some separate groups like receive, pay, and queue, pick and reorder, and then as the last step, the notification of the client. We use the API manager as the front to our microservices. Why do we do that? Well, there is a very good reason for it. The API manager allows you to manage, monitor, and perhaps even monetize your APIs. It is really a gatekeeper, making sure that the people who should be in can get in, and trying as much as possible to keep the bad guys out. So the API manager is the gatekeeper that will call a microservice that is running on the micro integrator, that will on its own right call several APIs. And basically, when you look at it from that level, it really doesn't matter whether you're using a real system like Stripe or you're using an API that we've created. Of course, when you look at a full-blown payment solution like Stripe, there is more configuration, there is more work to be done than the solution that we did. But nevertheless, it all boils down to one or two API calls. So this is the publisher. And then for the developers that want to use your API, there is the developer portal. I will go into details what that's all about. The reason why I'm telling it to you twice is that the demo that I'm going to give you is going to be fast-paced. I'm going to show you the flow. I'm going to show you the output. So it's good to already have heard the things that I'm going to talk about in a couple of minutes. Okay, so the developer portal, you can see here, you can see the Yuma Market API, but then specifically, not so much for the people who created the API, but for the people who are going to use the API, who want to know what's this API all about. When you look at the order, this is how we created it. The order API is an API that we've created using Integration Studio. The reason why we do that is especially for this purposes, but also for training purposes. And of course, I'm a trainer who does a lot of training in the stack of WSO2. So this makes it easy for people to understand what you're doing. So this is the order API. I'm going to flow through all of these steps in a bit. Then there is also the payment API, and you can again see that it's actually quite simple. It just shows you the high-level flow that is within the two APIs that we're going to call. And then finally, the whole backend is actually a number of databases that we connect to, either using the data services capabilities of the enterprise integrator slash micro integrator, or we're using the mediators that we can do to access databases or tables, insert, retrieve all kinds of information from that sort of stuff. So basically, what you see here are the 1, 2, 3, 4, 5, 6 databases that we've created in order to show you this use case. Okay, so let me see. There is an email that is sent out. That's another standard capability of the enterprise integrator, micro integrator. It's one of the transports that you can enable. We kept it quite simple, so we're using Mailtrap as our client, and you can basically see a very raw email coming into the system. Okay, so let's go to the next slide, and that's the demo. So let me see, I will start it and then I will talk you through it. It will be 4 minutes and 15 seconds about, and then I'm going to take a breath because it's going to be one go. Okay, so this is the order use case that we just saw. So the order is sent to the API, it's received, the individual elements are taken out of the order, the payment total is calculated, and it is sent to the payment API. If everything goes okay, it's put on a queue, it's a message store, and then a message processor will pick up the order, create a pick list, and send it to the order picker. The client gets notification when everything is done. So that's the high-level overview. And here we are in the API Manager Publisher. So here we can see the overview of the API as far as the configuration goes. You see the resources, you see the context. Here on the left side, you can see the design configurations, the runtime configurations, everything that you want or need to define for an API. But this is for the organization Yuma Market itself. This is for them because they have much more control because they're the owners as to the developers who are just going to use the API. And it could very well be that it's people within the same organization. The API manager support both. So we see the API credentials, the resources, the context, where the API is published on. We can try it out, we can rate it, we can comment it. So this is where the developers go to find the API. And then when the API is called, the order comes in. In the DB report, the first mediation, we enter a new record, we retrieve that value, and then we're going to look at the repetitive element of the order to get every individual line out of the database, into the database. We calculate the total, and we basically create a payload for the payment API for the amount of money that the person needs to pay. So when that's done, it will go to the payment API, and the payment API will retrieve, and hopefully it will do so. Yes, the payment API will retrieve the payload. It will deduct the money from the balance of the customer, and it will create an order picking list that we will put on a message store. And finally, we set a payload factory mediation saying that the order was actually paid for. So that's what's happening. But what does it look like when you do this in real world? Well, we use SOAP UI for this example. You can see the payload that I showed on a previous slide in the slide deck with the 3 different line items. If I click on post, it will actually give me almost instantly a message in JSON. That's the payload that was set, saying response is paid. So in this case, this is what you can see from the outside. When you go to the inside, it's actually a lot of things are happening. So I want to know whether the money is now in my bank account. So you can see there is one account with 742 euros. If I do another select, it's now 712 euros. So the money was actually deducted from this database. You're looking at a MySQL database, nothing more, nothing fancy. But that's not the only thing that happens. What also happens is that the email was actually sent from within the micro integrator to the inbox of the order picker. And as you can see, we look at the raw, it doesn't really make sense, but it is basically an XML SOAP payload that you can see here, but you can also make it look nicer by using all kinds of translations such as these. Okay, so I said I would take a breath. I just did that. That was a very quick explanation, and I can imagine that you have a lot of questions for us to answer. So with that, I think I'll give it back to Kasun, so he can chime in.
Yeah. So I think there are multiple questions. So there are a lot of interesting questions on microservices and API. So let me select one of those. So in the API first, so the question is in API first integration for microservices, security design will be repeated in API management as well as in the microservices. Yeah, so when it comes to security, it can be implemented at multiple levels. So usually at API gateway, you implement security for your APIs. At the same time, your internal services, the integration services or backend services that we talked about, they may also use security mechanism internally. It doesn't need to be the same technology or the standard, but it's very likely that you will expose something, an API using something like OAuth or JWT, whereas internal services are merely secured using transport level security. So it's fully decoupled, so you can select a choice in any technology of your choice. So there's another question on can my ESB integration be encapsulated into composite services in the integration layer? Or is my ESB investment lost? So I think it's a very good question because a lot of organizations have already invested into ESB. And my recommendation is to, you can use a cloud native or a decentralized integration technology such as WSO to build these independent integrations while keeping the existing ESB infrastructure as it is. So depending on for example, if you are a WSO ESB user and now you want to use decentralized architecture, so you can pretty much convert all your different integration use case into independent integrations. The only requirement of that is to have all the integrations independent, implemented as independent entities. So apart from that, integration runtime can operate as a single independent entity. So your ESB investment won't be lost, but either it can coexist with this modern decentralized part, or you can gradually convert them into the microarchitecture. Then there's another question. In microservices layer, is it good to start with Spring Boot and then go to Kubernetes and Cloud Native and so on? So I think when you're adopting microservices architecture, especially for the existing enterprise, you have to do that incrementally. So basically, you may have a lot of services and systems already built using different technologies. You cannot directly migrate them into a completely different architecture, completely different technology. But based on the APIs or integration services or microservices that you need a lot of agility and a lot of scaling, you can gradually convert them to decentralized architecture. So in that case, we can select technologies. If you want to build core services, fundamental microservices, then technologies such as Spring Boot may be the best option. There are various other microservices frameworks out there. And when you have to do integration, you need to have a integration technology such as AWS to cater these decentralized integrations. And obviously, Kubernetes will play an important role because when you have so many decentralized components, you need to have a good container orchestration engine and a good control plane to manage them. So, yeah, Kubernetes is, I would say, it's not an option. You have to go ahead with Kubernetes. So there are multiple questions on using different technologies to build atomic and core services. Yeah, you can select any technology of your choice to build these atomic services and integrate them using a preferred integration technology. So the key aspect of microservices architecture is you can select different technology. Even you can make your services polyglot, right? Which means you use different programming languages to implement different services. So that's a sort of advantage that you get from microservices architecture. Yeah, you can select any technology of your choice when building these different services. Okay, there's another question on. So there's another question on whether we always need to have integration services, and can the existing business services be directly proxied via the API management layer? The answer is yes, because in certain APIs, for certain APIs, you don't need any integration, right? So let's say you have a Spring Boot service and you want to expose this business capabilities as as a business capability, as a managed business capability, then you, without creating any integration service, you can directly expose them via the API management layer. So there's no any, it is not mandatory to have an integration, but usually in most cases, you need to do a lot of plumbing between different systems. That's where you need to have, you need to use the integration layer. Another question, there's another question on micro gateway. It should be deployed in the cloud or on-prem. So it should be deployed, you can deploy it, especially if you are using a cloud-based API management solution, such as WSO API Cloud, then you can use you can deploy the gateway in the cloud. But always it's not a mandatory thing again. So you can use on-prem API gateway as well. Okay, there's another question on when to use top-down versus bottom-up API integration styles. So it's more of a organization choice. So basically, if you're into contract-based service development, then I would say bottom up. The top down would be the best approach. So basically, you start off with creating APIs and then dive into the API implementation. So usually, the other aspect of that is when you have to build some business capabilities. So usually, you draft out the business capabilities of a particular function, and usually that is exposed to the external world. So rather thinking about the internal implementation details, you use API definition. You use you define the business capability using an API definition. So that becomes the top-down approach where you create the API first, and then when it comes to the implementation, you can connect different systems. And when it comes to the bottom-up approach, that's where you have let's say you have some integration already in place, and now you want to expose them as APIs, then that's where the bottom-up approach can come into the picture. But I would say you can use both approaches at the same time. So depending on the use case, it is not mandatory to stick to one particular approach. So there's a question on how API gateway should be configured to allow client-specific authorization. I think there are some details in our documentation site as well. I might not go into the details, but yeah, so it can be configured to follow different authentication schema based on different application types. How do we invoke an EI service from WSO API manager? So I think it's so for the API manager, EI service is another backend service. So that's where you create an WSO EI integration service, and use that as the endpoint in the WSO2 API manager. So we are working on actually bringing a more connected experience for that as well. So in the near future, you will get a much better user experience, more of a continuous user experience, so that you can create integration and easily convert them to a API in the API manager. But for the time being, you can use the EI services URL as the endpoint of the API manager, the API implementation endpoint of the API you create. Yeah, so I think we covered almost all the questions we had. So Rob, do you want to add anything?
No. I think that you answered already a number of questions, and it's good to hear that what we're doing basically is building on the stuff that we have been doing, but it also allows you to build new stuff. So it's basically a wedding between the old and the new. And when you look at the longevity of IT technology in our IT landscapes, there is so much old stuff still around that we use for several reasons. So this is actually the combination of APIs, microservices, but also the possibility to integrate older systems that makes this so very valuable. And that's it for me.
Yeah, thanks, Rob. There's a generic question on what are the advantages of microservices in business agility. Yeah, so when it comes to business agility, microservices allow you to create capabilities quite quickly. So because of it's independent from all the other work, all the other services. So you have the control over your business capability that you are building. So that's one thing, but it doesn't really say that you need to have you can immediately convert your existing systems into microservices and bring the agility into the picture right away. But it requires a lot of efforts because decentralized architectures are always hard to manage for the most part. So that's why you need to have a good infrastructure such as Kubernetes and good knowledge on, and also you have to follow the best practices, CI/CD, and again, you need to have a good understanding of the overall architecture that you are implementing. So if you do this in the incorrect way, this can be even more harder than managing monolithic application, right? Because at the end of the day, you are managing so many different services in a fully decentralized network. So if you don't have the right technologies in place, you'll be in trouble.
We still have 2 more slides that we can go to.
Yeah. Okay. So I think there's a question on WSO has multiple products, and it's really hard to understand the when to use what kind of a question. So I think then the question would be to select the product based on the use case. I would say for most of the common integration use cases, you will need API management and integration products. So we can consider it as a single platform. So API management is primarily to expose them as service managed services, whereas integration enterprise integrator to integrate all the different systems and services. So these two, although they are two products, they are pretty much part of a single platform. So again, we are working on making a better experience out of the two products as well. But based on the use case, I think you can select the products. Yeah. Okay. Rob, are you planning to cover the key takeaways or should I cover it?
You can do it.
Yeah, okay.
I can make you presenter.
Sure. Yeah. Sorry. Okay. Okay. Hope you can see my screen again. So, as the key takeaways from today's session, I would say API first integration is something that you should start investing into right away because it's something that you would let me go to the play mode. Yeah. So API first integration is something that you should start right away because uh, at the end of the day, what you are doing is you are creating set of services and connecting them and exposing them to external parties such as your customers, partners. So API first integration is a mandatory thing, and so you can do API first integration even without using microservices architecture. So even for your existing monolithic thing, you can do API first integration. And when you have the microservices in the picture, you can do a lot of decentralized implementations of services and APIs and manage them independently. And you will have the power of underlying Docker and Kubernetes platforms in that architecture. And API Manager primarily acts as the gatekeeper, fronting all your different internal services. Most of the business capabilities will be exposed via the API management. And containerized microservices will allow you to quickly add or remove different capabilities, different scaling needs, and so on. And you can have multiple services implementation. One services can be a core or atomic service, or you can have integration services using WS2 Enterprise Integrate. So, so those are the key takeaways, and we are working towards building more and more connected experience on microservices, APIs, and integration. So you will see a lot of changes, a lot of new improvements coming in the near future. So there are multiple resources. You can read our blogs, WS2 and Yenlo blogs, and there are multiple white papers on microservices architecture. I authored a couple of papers on how microservices has evolved and where it is moving towards. So again, at very high level, we would say the pragmatic adoption of microservices is the key, along with the API integration architecture. So with that, we would like to thank you. Thanks everybody for joining today's session. Thanks a lot for all the interesting and wonderful questions. So if you have any other questions, feel free to send us an email or contact our channels. Thank you very much.
Thank you.